In this video, I will be discussing enantiomers, diastereomers, and meso compounds with the different drawings of the same compound. So I'll first go over some basic definitions that are important to know before I start explaining enantiomers, diastereomers, and meso compounds. Specifically, stereoisomers are a type of isomer where the molecules have the same connectivity except for the arrangement of the bonds in space. This is important in the following slides because the molecules will differ by their arrangement of the bonds in space. So there are basically three main things to know about enantiomers. Enantiomers are a relationship between molecules, so one molecule by itself cannot be an enantiomer unless it's in relation to another molecule. The two molecules must be mirror images of one another, chiral, as I discussed in the previous slide, and essentially be different molecules. So we'll look at this molecule over here. The enantiomers of this molecule would look like this. They're mirror images of one another, chiral, and different molecules. And you can see here in this example that when there are two stereocenters in a molecule, it works the same way where when there are no planes of symmetry and they're essentially different molecules. So now, if we look at diastereomers, diastereomers are essentially stereoisomers that are not mirror images of each other. So, for example, if we look at the same molecule, the last one from the last slide, we'll see that the diastereomer looks like this. It doesn't matter whether you change this stereocenter or this stereocenter, but they should not be mirror images of one another. And you can see here that I just chose to change this stereocenter, although it really doesn't make a difference whether you moved this one or this one, as long as only one of them is changed. Meso compounds are compounds that have stereocenters but are achiral due to a plane of symmetry. So, for example, when we look at this molecule, there's a stereocenter here and a stereocenter here. However, there's also a plane of symmetry that runs through here because everything on the top is an exact replica of everything on the bottom. So, because there's a plane of symmetry, the molecule is achiral and therefore meso. So here's a sample problem, and I challenge you to pause the video and draw the enantiomer and the diastereomer of this molecule here. So the two possible enantiomers that you could have drawn would look something like this, where it can either be exactly a mirror image, or you simply need to switch both of these so that if it was facing forward, it's now facing back, and if it was facing back, now towards the front. And the diastereomers would look like this, where instead of changing both of these, you simply change one of them, and it could look like this molecule here or this molecule here. And something to note is that these two molecules here at the bottom, the diastereomers, are meso compounds to each other because they are the same identical molecule. Now here's a brief overview of everything that's been covered in the video. Something to ask yourself when looking for these isomers is whether the stereoisomers are mirror images of one another. If yes, and they're superimposable mirror images, then they're the same molecule, or meso. If yes, but there's non-superimposable mirror images, then they're enantiomers. And if they're not mirror images, then they're simply diastereomers.